An envelope is a tool that helps us automate aspects of the sound. It generates a slow and evolving waveform, which can then be used to modulate different parameters of our synthesizer, such as volume, pitch, and timbre. The ADSR envelope gets its name after its 4 stages: attack, decay, sustain, and release. The attack, decay, and release are all time parameters, while the sustain is an amount or level parameter. The attack time describes the time it takes to gradually fade from minimum to maximum. This stage steps into action the moment you play a note. Longer attack times will fade in slowly, while shorter attack times will fade in faster, even instantaneously if you wish. And of course you have all of the attacks in the middle. The decay stage switches in once the attack is finished, and it describes the time it takes to gradually fade from the maximum position, which is the end of the attack stage, to the level of the sustain. Let me remind you that the sustain is a level parameter. A short decay will result in a fast drop to the sustain level once the attack stage has finished. A long decay will slowly fade to the sustain level. The sustain stage is not a time parameter. It is infinite in time. Once an envelope has finished going through the attack and decay stages, the sustain stage will stay at its level as long as you keep your MIDI note held. As you see, I'm still holding the note, and once I let go of the note, it will switch to the release stage. The release stage controls the time it takes to fade out from the position of the envelope once we let go of our MIDI note until it reaches 0. Now I'm holding the key, and once I release my key, it will gradually fade. Short release times will result in a fast drop to 0, while long release times will fade out slowly once the MIDI key is let go. Now that we've described the envelope's parameters, let's look at some common uses for the envelope. The envelope is used to modulate the parameters of a synthesizer. What do I mean by that? Synthesizers have an array of parameters to control the sound. Each knob on a synthesizer is such a parameter. For instance, in this case, I've chosen to enable modulation for 2 parameters. One is the pitch of the oscillator, and one is the filter cutoff. To make the parameters follow the movement of the envelope, all I need to do is to turn the modulation knob up. The purple bar located on the pitch knob helps us visualize the actual position of the pitch parameter. If I turn the modulation knob up, I get a bigger modulation range. Any parameter you modulate acts as an offset to the modulation. For instance, if I move the knob up, this new position will act as the starting point for the envelope. If I move it down, the other position will act as a starting point for the envelope. To tune the envelope's modulation range correctly, first turn the modulation knob off, then tune your desired minimum with the main parameters knob, in this case the pitch knob. Okay, this is the low note I want to reach, and now boost the sustain up, wait for the sustain to reach maximum, and now while you're on sustain and it's on maximum, you can tune the maximum of your envelope. This means that this here will be the maximum the envelope will ever reach, no matter how I tune it. So let's see now. That's great. Now the envelope is acting exactly the way I want it to. It has the right minimum and the right maximum. Remember, the parameter provides an offset for the modulation. Let's try the same thing with the cutoff modulation. This is the knob, and we want to move it with the envelope. Notice that the cutoff, like many parameters in the synthesizer, has an endpoint. It reaches a maximum. This is a ceiling point that it cannot push through. It cannot go over this point. So, however modulation you push, the sound will not be altered if you select the maximum as your starting point for the modulation. This is a common mistake in envelope tuning and you should avoid it. Remember, you need to set your maximum with the modulation knob, and this maximum should not exceed the maximum of the original parameter. Let's talk about some general points about the behavior of the envelope. First of all, when the sustain is on maximum, the decay value is meaningless. Why is it meaningless? Because if you remember, the decay is the time it takes to reach from maximum to the level of the sustain. Since the sustain is on maximum, the decay will just move from maximum to maximum and will have no effect. Let's look at the graph. Once I trigger a note, there is a white line that shows where the envelope is, and try to listen if you hear any difference between a long decay or short decay. That's right, there is no difference. When the sustain is on maximum, the decay value is meaningless. Now I made a long envelope, and if we look at the white line while I play a note, we will see that once I release the note, it will jump straight to the release stage, no matter at what stage I was in the envelope. However, this graph is a bit misleading because the release does not start from the level of the sustain, but rather from the level the envelope was when I left the note. So for instance, if I play a short note and let it go quickly, the envelope will not have time to rise to the maximum, and the release will continue this low level until the fade out once I release the note. If I let it go to maximum, the release will continue from there.